This is the walkthrough video for PCTC 2023 Round 1 Senior Question 6 printer paper. So this question is pretty much like the previous one. We need to decode all of this random nonsense to figure out what the maths problem actually is. But yeah, we're given some information about this printer, and we need to figure out we need to figure out how many pages of paper that we need to print all of this stuff out. So first off, let's just input our three variables. That's going to be n, p, and a letter. And so n is an integer, p is also an integer, and then the letter is obviously just a letter. And now the way we're going to approach this problem, and there are so many different ways to do the maths. You can simulate it. You can really just do whatever. But I'm going to do it my way again. So the way we're going to do this is we're going to take an n, which is, for example, in this case, 15, and we're going to assume that we need 15 pages. Because 15 pages is the absolute maximum amount of pages you need for 15 sides. Because that's what happens if, for example, p is 1, so you only want to print one page per piece of paper, and if the letter is s, so you're only printing off the paper single-sided. So essentially, our initial number, we're treating n as our maximum number of pages that we need to use. But as we're given more information, for example, if you can print more pages per side, then we'll chop down n as we get our inputs, and therefore by the end of the program we should have an n that accurately represents how many pieces of paper we need. So the first thing to deal with is the p input, which is the amount of pages per side of piece of paper. And so all we're going to do here is just do n divided by p, because if you imagine, for example, we want to print off 8 pages, and we have I'm printing off 2 pages per side of piece of paper, and we're using single-sided paper, then we only need 4 pages in total. And so we just chop it down by doing division. Now to deal with the third input, which is going to be the lowercase character, we're going to check if the letter is equal to d, and if it's equal, so if it's double-sided, then we do something. If it's single-sided, we do nothing. Because if it's single-sided, we kind of come back to this idea where we don't need to chop down our maximum estimate, which is n. We can just leave it as it is. But if it is d, then we need to chop down our maximum estimate of n, and we need to chop it down by a factor of 2, because we've just doubled the amount of pages. We just double the amount of pages that fit on a piece of paper, and so we can chop it down by 2, by a factor of 2. Now the final thing to do, which is actually probably the hardest thing to do, is to print off the correct answer, because at this point n is almost certainly going to be a float, because we've done division on n, but we haven't done integer division. Like, we haven't done a double-slash integer division. We've done normal division, which we have to do because we don't necessarily know that these two numbers are divisible by each other. For example, in this example input, 15 divided by 4 is not a whole number. It's like 3.75 or something. And therefore, we need to preserve that information by using single division. And therefore, n at this point in time is a float. It's a decimal. Whereas we obviously just want to print off the amount of pieces of paper we use, right? Like, we can't use 4.3 pieces of paper. We can use 5 pieces of paper. We can use 4 pieces of paper, but not 4.3. And so we need to figure out what we're using. Now, the reason this is actually difficult is because, for example, n might be 4.0. And if n is 4.0, well, you just want to print off 4. If n is 4.2, for example, then we want to print off 5, because we don't want to round down to 4, because once you've used 4.2 pieces of paper, you just have to round up to 5. It's this idea, like, if you eat 3.5 bananas, you still used up 4 bananas, because you still had to pick up that 4th banana and peel that 4th banana. And so we want to round up in this case. And so how do we check to see whether n is a whole number? Because if n is a whole number, we just print off the integer version of n. If it's not a whole number, then we have to round up. And so the way we do that is by doing this. So if the remainder of n divided by 2 is, n divided by 1 is equal to 0, then it's a whole number. Then we know it's a whole number because, well, it's divisible by 1. Anything that's divisible by 1 is a whole number. And so all we're doing is checking to see if it's divisible by 1. And if it is, then it's a whole number, and therefore we can just print the int of n. And int will just convert n into an integer. Now, if it's not divisible by 1, then it's not a whole number, and therefore we need to round up. Now, what int does in Python is int automatically rounds down. And so we can just int the number, which turns it into an integer, which is good. And then we can add 1 to ensure that we do the rounding up. And then this should hopefully work. But yeah, there are a couple of nuances and subtleties with this question which you might have to look out for.